Hi everybody, today is Monday, October 31st, and I'm just telling you right now, my dogs are upstairs in my living room. I'm actually recording this on Sunday night. My dogs are upstairs in the living room. They're playing really nice right now, but they could start growling at each other any minute. So, warning, I may have to take a break to correct my puppy dogs. All right, so today is Monday, October 31st. So let's go ahead and go into Schoology. Let's take a look at our objective today. So basically what you guys are going to be held accountable for today is to make sure that you can explain the relationship between plate boundaries and tsunamis. And I've got a couple questions, actually 3 questions later on that it's very important that you know the answer to. Today, our activity is plate motion engineer internship. You're going to be in day 2. There is a lab today, so if you're absent, you need to schedule time with me to come in and complete this activity. And then the homework is by the end of class, you should have read chapter 3 and annotated chapter 3 in order to find out the answers to the 3 questions. And I'll show you those 3 questions here in just a minute. Okay? All right, so coming in here real quick, the bell ringer activity today, we have this model, no, there they go. I have this lab sheet. And I had a hard copy in class, or kids could use a digital copy. And so I'm going to go ahead and just give you an opportunity to put this in GoodNotes if you want to use a digital copy, or when you come back, if you want a hard copy, you can have that. And I'll explain what we're doing with that in a little bit. Once you are finished with that, pause this video until you're ready to go, okay? Okay, I'm assuming you're ready to go. We're in day 2, modeling a tsunami wave. You guys need to log into Amplify. You're going to be in plate motion engineering internship. Click on day 2, and then you're going to go into activity number 1, and that's how we connect to our Futura workspace, remember? So you've got this blue link right here that says Futura workspace. Go ahead and open that. And then there's going to be a new daily message from your project director, just letting you know what's going on today. So I will give you a minute to read your daily message, pause this video, and then when you are finished, go ahead and start to play it again. All right, we're just reviewing the different parts of a daily message. So the daily message tells us a focus for each day, and our focus today is that we are going to be looking at the relationship between plate boundaries and tsunamis. And then each message is going to include some key ideas and a list of deliverables or tasks that you need to do. So we've got these 3 deliverables today. We also learned that you can keep notes to keep track of important information. And so I went ahead and had the kids go ahead and click on this and just practice taking a note. So go ahead and click on where it says new note. And then I'm going to have you guys just type in day 2, understanding tsunamis. So that's the day, and that's the subject of our message. And then I want you to include 3 important pieces of information that you should record from today's daily message. So first of all, we will be completing the task for modeling a tsunami wave. So you've got that worksheet. And then I want you to write down, do all earthquakes cause tsunamis? That's kind of a focus on today. We're looking at plate boundaries and tsunamis, and we're looking at earthquakes and tsunamis, and we're just kind of really continuing our research by pinpointing exactly what plate boundaries and what types of earthquakes cause tsunamis. And then we're going to do that by skimming through chapter 2 to answer the question and add any annotations if you need to. And then also we're reading and annotating chapter 3 for the first time. Lots of information there. Okay, pause this video until you've got everything printed out or typed up, written out right there. And then go ahead and push play. All right. So for each daily message, you'll return to your daily message notes to add new information. Basically, every time you open up a new note, you'll see that daily message note up at the top in that white. And then from now on, you're going to go into daily message every single time to write down what our tasks are going to be for that day. All right, so in class today, we modeled a tsunami wave. And this is just to kind of remind you that our task is to design a warning system to help people evacuate in case of a tsunami. And I had the kids put away their iPads because we were working with some real water and I didn't want to get them wet. We reminded each other that a tsunami is a large ocean wave caused by a sudden shift in the sea floor. And I've got 2 videos I want to show you. They're very, very short. They're showing 2 different visualizations of a tsunami in the Indian Ocean. And I want you to notice that the area that we're concerned with, Sri Lanka, is circled in that top part of the video. And in both of those parts. So you can see where the word Sri Lanka is circled in yellow. But then look at the second video on the bottom. That area right there, it's you can see India, but then off to the southeast, the Indian coast, that little island right there, that's Sri Lanka also. All right, so let me show you this. There's no sound here. This is a computer-generated tsunami of what happened in 2004. So you can see that we've got these waves that are generated right there off the coast of, I think Thailand. This is Thailand over there in Sumatra. And you can see how it traveled all the way over to Sri Lanka. I'm going to show you that view again here in a second. We're going to see view number 2, and you're going to see different colors. So there's a red and yellow and then blue colored wave as it goes by. And they go so quickly, and I want to show this to you again. Okay, so look at view number 1. So we follow that first wave as it travels across the left part of your screen. This is called like the first wave or phase 1 wave. And you can see right there it hits Sri Lanka, and so that would be the tsunami. But what I really want you to look at is the first and second wave. So look at the yellow and then look at the blue. So you can see that there's not just one wave. It actually has 2 waves that are going just back to back. And we talked in class about the different waves. We watched them multiple times. We saw how the waves traveled across the entire ocean. So it generated right over there by Sumatra and off the coast of Thailand, and it traveled all the way across the Indian Ocean, and it ended up even going across over to the coast of Africa and hitting there. We talked about how some of the waves hit Sri Lanka, but then they went back towards where they came from and hit the coast of Sumatra again. We talked about the different types of, just based on how deep the colors were, the amount of energy that was being transmitted across the ocean. And so we kind of want to just identify that tsunamis can travel far across the ocean. And even if they're not right near, even if they're not right there where the earthquake is, they are at risk. So it's really important that our warning systems are up to date and they're modern and they don't have any false alarms. Okay, so then we've got this model, and it was a paint tray. And we're going to use this physical model to learn more about tsunami waves. Let me just kind of explain the different pieces of the model. And then I'm not going to really talk too much about it. I'm going to have you come in because you're going to have to experience this for yourself. But it's a paint tray. And then I've got little houses like what you would use in Monopoly. There is a see-through or transparency sheet. It's kind of that acetylene sheet of, it's not really paper, but it's not plastic either, but you guys know what I mean when I say transparency sheet. That's taped on the bottom of that tray. And then we also had some straws, and I filled that up with a little bit of water up to a certain point. And then I asked the kids to model 2 different types of waves. And you can see over here, this is the front page of your modeling a tsunami wave lab sheet. I asked the kids to model a wind-driven wave. And it's obviously a wind-driven wave is caused by wind, but when we modeled it, we used the straw. And then we wanted to look and see and just make some comparisons between the wind-driven wave. And then I asked the kids to try and model a tsunami wave. And there's a special way that you want to do it. And I'm not going to talk about it now because it doesn't really make any sense to you. And so once you are able to compare those two waves, then you can answer the rest of the questions on the lab sheet and then turn that in. Okay? All right. So the next activity is reading about plate motion and tsunamis. We're going to take a look at chapter 3. This is pages 7 through 9 in your dossier. I want you to continue your background research by reading and annotating chapter 3, plate motion and tsunamis. And let's start by numbering each paragraph in chapter 3. So obviously we've got the first 3 paragraphs here, and then you'll continue on page 8 and page 9. The reason why we did this is because in class we were answering the questions out loud and just making sure everybody was able to cite the source or cite the location in the textual evidence, so everybody could see it and highlight it and make sure that they've got that annotation. All right. So in addition to your own annotations, I want you to, you might want to highlight vocabulary, or as you're reading, you've got some questions. And then as you read even further, you get answers to your questions. But in addition to all of that, I want you to locate the answers to these questions. And these are the 3 questions that are very, very important. You need to make sure that you know the answers to these. Okay. So I'm going to read them and I want you to pause them, and I want you to pause the video, and then I want you to write down these questions. Super, super important. Go to chapter 3 and write them down so that you can answer those questions. The first one is, does plate motion always cause tsunamis? We know that plate motion causes earthquakes, and we know that it causes volcanic activity, and we know that plate motion does cause tsunamis. I want to know, does it always cause tsunamis? Second question, is there one type of plate boundary that is most likely to cause a tsunami? And then the third one is, do all earthquakes cause tsunamis? And if not, which ones do cause tsunamis? In fact, I'm looking for a specific number. If you were there on Friday, we talked about the Richter scale. And typically that is a 0 to a 10, and the higher the number, the more force or the stronger the earthquake. And so I'm looking for a specific number assigned to an earthquake that would be more likely to cause a tsunami. That's very important for you as you are gathering evidence to prepare your model. Okay, pause this video, write down your questions. Okay, I'm going to not go through the answers with you. I want you to go ahead and read and annotate. And then we just talked about going back to chapter 2. I want everybody to reread the last paragraph in chapter 2 and add to your annotations. And again, you're reading with a new focus. Do all earthquakes cause tsunamis? It's right there in that paragraph. See if you can find the answer to that question. Okay? All right, hope to see you soon. If you have any questions, let me know.